Hello. For this chapter, we have 3 video lectures, the first of which will introduce you to some of the concepts involving electronic health records. Okay, as mentioned, this video lecture will cover the foundations and the evolution of EHRs. So again, as we talked about earlier, the health information management profession is moving from something that used to be entirely paper to something that's entirely electronic. In addition to that, we used to have people working on site. Typically, medical records departments, as we called them, were located in the basements of hospitals next to radiology, pathology, and what have you. Now, of course, we have very few people on site, maybe just a couple people to handle release of information requests at the hospital. Everybody else can work in another part of the town, in another state, or even around the world. So it's entirely different. Health information management professionals have patient information management skills that assist facilities in making the transition to electronic health records. Even though a lot of what we have is now electronic, the profession continues to evolve just like technology continues to evolve. There are new demands from the Centers for Medicare and Medicaid, and these change all the time. So there'll be plenty of work for all of us in health information management. That's why it's critical to understand the role of technology in HIM. Couple things in order to talk about electronic health record systems, we have to know some basics about some computer terms, which I'm sure isn't a problem for nearly all of you or all of you. But when we talk about hardware, we're talking about physical equipment, things we can touch. These are keyboards, laptops, tablets, computers, all these things. And within the hardware, we have several different components. We have the CPU, which controls the processing of information. This is a chipset. This is the motherboard, the disk space, all these things. It's all controlled by the CPU, right? The CPU controls everything that goes out to the rest of the hardware. We also have input devices. These are mouse, keyboards, voice activated transcription, anything that allows data and information to go into the system is an input device. And then, of course, we have output devices. These could be computer displays to display a digital image of an X-ray. These could be transcribed text. This could be audio files. All these things that display this type of information are output devices. And then, of course, we have storage. We have hard disks, we have solid state disks, we have cloud computing. Regardless, it all does the same. And then in order to connect these things, we need networking equipment. These include the Ethernet tape cables, the modems, the routers, the switches, all these things that connect different computer workstations to everybody else on the network. Now we get into something as software. We have software, which are things that we can't necessarily touch, but they're all there. This is software. And we think of software as being Excel, Access, Word, PowerPoint, a suite like Microsoft Office 365. But actually, that is just one type of software. That's application software. That's the type of software that allows a computer to do a specific task. Things that are common to all different types of application software, like saving, deleting files, things like that, that's called operating system software. And examples of this are Unix, Windows 11, all these different things. So how did we get to where we are now in the 70s and 80s? Most computerized medical record systems were large. They were mainframe oriented, and typically you accessed a limited amount of data through these big computer displays and a keyboard that looked like a large TV, right? And these were 3270 dumb terminals, and it was very, very limited. And then as we got into the 1980s, we had more network computers. We had a movement to PCs and in some cases Macs and Unix systems, right? So it was more of a longitudinal patient record. And we could only do that with computer-based records. As we got into the 90s, we had more and more things being automated. We had automated systems that merged dictation. We had digital dictation systems. So instead of the old days where providers would dictate notes on tape and they'd be typed up by transcriptionists, they would just pick up a phone from anywhere and dictate it. We had scanning, we had document imaging, we had optical disc imaging, all these different things in the 1990s. And scanning used to be a very, very popular thing. This is document imaging, right? Typically, for every inch of filing space, you can have right around 100 pages of documents. Now, of course, with things being scanned, right, we can have something that is just stored on a computer. Multiple people can access it once. It's really, really good stuff. However, the big problem with scanned pages is they need to be indexed. So in other words, they need to be identified to the right patient and the right type of document. And a lot of facilities did and still do this by using barcoding. And these are the UPC codes that allow things to scan it and says this particular document belongs to this patient and is a progress note or a discharge summary or what have you. And again, these still evolve, excuse me. So the next evolution is all this data goes into what we call a clinical data repository, right? Which is kind of like a central warehouse where all this different data gets indexed and stored. And people in the trade call it the CDR. And when we talk about the term electronic health record versus electronic medical record, for our purposes and the purpose of this class, the electronic medical record is the system that's based on the imaging and merging of data from these different standalone systems. So as the text says, an electronic medical record is the electronic record of health-related information on an individual that can be created, gathered, managed, and consulted by authorized clinicians and staff within one healthcare organization. Now we have the next step in that is a health information exchange. So kind of taking the same concept from clinical data repository and spreading that over multiple organizations, we can now have all this health information stored in an exchange. And we see several of them. California has had them, Oregon has them. And these are exchanges where patients can store their records. And as they travel between different healthcare systems, these can be accessed and used. Electronic health record systems are somewhat like an exchange, but typically they're within one organization. And we see that with KP Health Connect. If you're a Kaiser member and you have records in Northern California, as I do, or Southern California, or KP Northwest, all these can be integrated. And we'll talk more about that, some of the challenges with that when we talk about interoperability. And then as we transition to electronic health records, we see a term called hybrid health records, and that means exactly what it says. Some of the documentation remains on the paper and other parts are all electronic. So for instance, at Kaiser Oakland where I worked, a lot of the labs and the x-ray reports you could access without a chart. The narrative, if you would, the progress notes, clinic visits, discharge summaries, those were still paper information and you needed the paper chart to see those. Some issues that impact the electronic health record include we need to define what it is. Now we have scheduling, we have pharmacy records, we have receipts, we have administrative things. So we need to define clearly what the legal record is. And then secondly, we need to talk about when these records are completed. Most EHR systems providers can create notes and they're not final and uploaded and viewable to the rest of the users on the system until they authenticate or sign the information. And there are different policies on that. But just like in the paper world, if you don't have these records completed, a discharge summary or a clinic visit from 3 months ago, and you're completing it 91 days later, it's of less value, right? So it's important for these policies and procedures to address how quickly these records are completed. And again, HIM professionals and IT professionals need to work together to figure out exactly what's going to be hard copy, what's going to be scanned, and so on. And again, we talked about health information exchanges a little bit ago, but basically this is allowing facilities of different organizations to share health information, right? It's basically an electronic network that's from multiple different healthcare systems. In California, for instance, we had the VA that shared data with Kaiser, that shared data with Santa Cruz General. San Diego Health Information Exchange had all different types of people, Kaiser, the VA, the County General Hospital sharing this information. And these regional health information organizations were established by collaboration of the different stakeholders. Who are the stakeholders? They're the hospitals, physicians, the patients, the health plans, government agencies. And that's all I have for you. Come back and we'll talk more about the legal issues that challenge us exchanging information and other concepts in the second video lecture for this chapter. Bye now.